Number 2, we want to find the domain of this function in interval notation. So it's a negative function. You can put the negative with the numerator or the denominator. I'm going to put it up here so we can forget about it. And then remember to find the domain. We take the denominator and we set it equal to 0. So to solve this, we want to factor it. So do these have anything in common? They both have an x, right? So we're going to take out an x, and we're left with 1x and a 5. So this is factored form, where one of our factors is just x. So when we have factored form, we take each factor and we set each factor equal to 0. So for this one, we don't have to solve, but we have to solve this one. So x equals 0 and x equals -5, those are our asymptotes. But for domain, that means x cannot equal 0 and x cannot equal -5, because those are asymptotes. Okay, so I have the graph here, already entered. We can see our asymptote at 0 and at -5. So I want to write on this. Let me see if I can pull it into this document. Maybe. Maybe I can write on the graph. Okay, so we're looking at x values. And we want intervals. So here's our values that x cannot be, -5 and 0. So I want you to look at how many lines there are in between. We have 1 here, 2, it's not very even, 3. So that means in our answer, we're going to have 3 intervals. Okay, so let's go one by one and we'll join them with the union. So go left to right. We're out here forever and ever and ever at -infinity. And we go until really, really, really close to -5. That's our first interval. And then we have another one, and we separate them with the union. And then this one, we're really, really, really close to -5. And then we're really, really, really close to 0. So we're going to use parentheses because that means we're not actually getting to -5 and we're not actually getting to 0, but we're really close. And then a union. So here we're at 0, and then we go all the way out forever to infinity. So 3 intervals join with a union, and that's our domain.